Welcome back to Math Brain channel. This is a resource channel for high school mathematics, covering a broad range of topics. This is the second video on the simultaneous equations series. In this video, you will learn how to solve a pair of simultaneous equations which have no balanced variables. Let's get into it now. Here are two equations. In equations A and B, none of the variables, x or y, is balanced. Equation A has one x and two y's, while equation B has two x's and three y's. None of the two variables, x or y, is in equal quantities in both equations. Let's see what happens when we multiply every term in equation A by 2. When every term in equation A is doubled, the equation remains valid. It only changes its form to fit the purpose of this process. Here is the new, but equivalent equation. 2x plus 4y equals 10. We now copy the original equation B, just below the new modified equation A. Ensure the like terms are lining up vertically, the x's are lining up, y's are lining up, and the numbers too. Note now that both equations contain x in equal amounts, 2x each. That's why we doubled equation A. Let us now subtract the two equations, A minus B. 2x minus 2x equals 0x. We do not need to write down 0x. 4y, minus negative 3y, equals 7y. 10 minus 3 equals 7. X is now eliminated. In the resulting equation, y is the only variable. 7y equals 7. Pause the video and solve for y yourself. Then check your answer below. You just needed to divide by 7 on both sides, which gives us, y, is equal to, 1. What was your own solution? Congratulations if you got it correct. Let's now use the value of y to solve for x. Take equation A, in its original form. Here it is. Now we place 1 in the place of y. First we do 2 times 1, which gives 2. This means, x plus 2 equals 5. What value of x fits the bill here? To find x, simply subtract 2 from both sides. X is equal to 5 minus 2. So x is equal to 3. That's it. Both x and y are now known. Plug both values in equation B and ensure it holds true. This is always a good practice before leaving this question. Once you have tested equation B, we are ready to move on to the next example. Here is a new pair of equations. In equation A, 3x plus 4y is equal to 11. In equation B, 2x minus 5y is equal to 15. Again, like in the previous example, none of the variables is balanced. But, unlike the previous example, balancing the variables is a little less obvious. There are several ways to balance whichever variable we choose to eliminate. Method 1. Let us balance variable x by multiplying equation B with 1.5. This is because equation A has 1.5 times more x's than equation B. How do we know this? Take the number 3 here, and divide it with this number 2. These numbers are known as coefficients of x. The number before each variable is called the coefficient of that variable. Can you identify the coefficients of y in each equation? Give it a try. In equation A, the coefficient of y is 4. In B, the coefficient of y is 5. Congratulations if you got both correctly. We shall be dealing with these later, in method 2. An important quick note: if there is no number written before a variable, its coefficient is 1. We usually do not write 1 before a variable, but it is implied by having no number. Thus 1x is usually written simply as just x. So now, let us divide the coefficients of x. 3 divided by 2 is equal to 1.5. This is the number with which we multiply equation B. Every term in B is multiplied by 1.5. Here is the modified equation B. Now we copy equation A, without modifying it, so that it's directly above the new equation B. Ensure the like terms are lining up one below the other, as shown earlier. Now we have 3x in both equations. Since both are positive, they will be eliminated by subtraction. Subtracting gives us this new equation, with only y as the unknown variable. Solving the equations from this point will follow steps similar to those shown above, in the first example. We leave it to you to work it out and solve for x and y. This is an excellent opportunity for you to practice what you learned earlier. Pause the video to complete solving the equations. Then continue watching to learn alternative methods. The answer will be given at the end of this video. Method 2. Here are the original two equations again. This time round, we shall aim to eliminate y. To balance y, and hence eliminate it, we shall multiply equation A by 1.25. From method 1, you should figure out where the number 1.25 came from. We simply divided the coefficients of y. 5 divided by 4 gives 1.25. Let us multiply A with 1.25. When we do, we get this modified equation A, which is equivalent to the original one. Now we copy equation B, unmodified, right below the modified A. We now have 5 y's in each equation. Y is balanced. Note, however, that they have opposite signs before them. The top is positive 5y, and the bottom one has negative 5y. When we add the two equations, the y's cancel out. Adding will eliminate y, to give us this new equation. 5.75x on the left-hand side, and 28.75 on the right. If you choose, you could instead divide 4 by 5, to get 0.8. Then multiply equation B with 0.8, and y will be balanced. You could try this later on your own, to get additional practice. We leave you now to complete the solution. Check the correct answer at the end of the video. Method 3. Some of us prefer working with whole numbers only, and it is understandable. Whole numbers are easier to work with, and less prone to mistakes. If you are such a person, method 3 is here for you. Here are the same two original equations. In this method, both equations require to be modified, in order to balance one of the variables, and still retain the whole numbers. The first step is to decide which variable we want to eliminate. Let us show you how to eliminate x in this case. Later, you can use the same technique to eliminate y, as additional practice. To eliminate x, we multiply equation A with 2. And multiply equation B with 3. These numbers are the coefficients of x in both equations. Put simply, we interchange the coefficients of the variable to be eliminated. So we take the coefficient of x in equation B, which is 2, and multiply the whole equation A with it. Likewise, we multiply the whole of equation B with 3, which is the coefficient of x in equation A. When you write both modified equations here on the right, you notice each equation has 6 x's, and both are positive. Just subtract the two equations, and x is eliminated. Following the steps shown in the first example, proceed to complete the solution. Pause the video to do this. Methods 1, 2, and 3 are alternative ways of eliminating variables in the original equations. None of them is superior, it is just a matter of preference. Choose the one you prefer, and practice until you fully master it. If you have completed the solution correctly with any of the methods, you should have got x is equal to 5, and y is equal to -1. If you got different values, rewind the video and carefully check your working to discover where you might have made a mistake. And now, before we conclude this lesson, a quick word about rearranging equations. So far, all the equations have been presented in standard form. Here is standard form. Ax plus by equals c, where a, b and c are numerical constants. Put simply, standard form means that the term with x is written first, followed by the term with y. The number without variables appears alone on the right-hand side of the equal sign. In this case, a equals 3, b equals 4, and c equals 12. Here are 3 more equations. Clearly, none of them is presented in standard form. Please pause the video and try rearranging them each into standard form, using the example given above. After that, you can continue and check the correct answer. Why do we require standard form at all? Expressing equations in standard form has several benefits, but let us discuss only that which is directly relevant to this lesson. When you write a pair of simultaneous equations one below the other, having them in standard form helps you see immediately if the variables are balanced. Then when it comes to eliminating one variable by adding or subtracting, the like terms are already lined up vertically, and the process is easier and faster. So now that you know, if you are given a pair of linear equations to solve by elimination, the first thing to check is if they are both in standard form. If not, you need to rearrange them as shown above. Then you can go on to solve them as shown earlier.